Azure Storage. Azure Storage is a Microsoft cloud storage solution for modern data storage scenarios. Azure Storage is a service that you can use to store files, messages, tables, and other types of information. Azure Storage can be used as a store for websites, mobile applications, desktop applications, and many other types of custom solutions. Azure Storage is also used by virtual machines and also cloud services on platform as a service. You can generally think of Azure Storage in three categories. One is storage for virtual machines. This includes disks and files. Disks are persistent block storage for Azure Infrastructure as a Service virtual machines. Files are fully managed file shares in the cloud. Unstructured data. Now, this includes blobs and data lake stores. Blobs are highly scalable. They are REST-based cloud object store. Data lake store is Hadoop distributed file system, also called as an HDFS. Structured data. Structured data includes tables, Cosmos DB, and Azure SQL DB. Now, tables are nothing but just key value pairs. Cosmos DB is a globally distributed database service. Azure SQL is a fully managed database as a service built onto SQL. We will talk about these individual components one by one in the subsequent videos. Azure provides storage with the help of a service offering called as Azure Storage Accounts. Depending on your purpose and need, you would use blobs, files, tables, or queues. Let's talk about the use cases of each one of them one by one. Azure Blob Storage. Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data, such as text or binary data. Blob storage is ideal for serving images or documents directly to a browser. So if you got your website or your web application, you can keep your pictures, videos, images in the blob storage. Blob storage can also be used for storing files for distributed access. You can stream videos and audios directly from the blob storage. Blob storage can also be used for storing data for backup and restore, disaster recovery, and also archiving purposes. Storing data for analysis by an on-premise or Azure hosted service can also be done in blob storage. Objects in blob storage can be accessed from anywhere in the world through an HTTP or HTTPS connection. Users or client applications can access blobs through URLs or through REST API calls, PowerShell, or CLI. The storage client libraries are available in multiple languages including .NET, Java, Node.js, PHP, Python, or Ruby. Azure Files. Azure Files enables you to set up highly available network file share that can be accessed by using the SMB protocol. That means that multiple virtual machines can share the same files with both read and write access at the same time. You can also read the files using REST APIs. One thing that distinguishes Azure Files from files on the corporate file share is that you can access these files from anywhere in the world just by using a URL that points to the file and includes a shared access signature for security purposes. You can generate the shared access signature tokens that will allow specific access to a private asset for a specific amount of time. When do we use file shares? File shares can be used in many common scenarios. Some of these are using file shares for migrating your on-premise applications and data to Azure. Many on-premise applications use file shares, and this feature makes it easier to migrate those applications that share data to Azure. That means if you mount the file share to the same drive letter that's on-premise application is using, then the part of your application that accesses the file share would work with minimal changes. Configuration files can be stored on a file share, and that can also be accessed from multiple virtual machines. That means tools and utilities used by Multiple developers in a group can be stored on a file share, ensuring that everybody can find them and then they use the same version. We can also use the file share for diagnostic logs, metrics, and crash dumps. And these are just three examples of data that can be written to a file share and processed and analyzed later on. Queue storage. Azure Queue Service is used to store and retrieve messages. These are usually done by applications. So when applications receive or store messages, Azure Queue can be used to store such messages for the applications. Queue messages can be up to 64 KB in size, and a queue can contain millions of messages. Queues are generally used to store lists of messages to be processed asynchronously. For example, say you want your customers to be able to upload pictures and you want to create a thumbnail of each picture. You could have your customer wait for you to create the thumbnails while uploading the pictures. An alternative would be to use the queue. So when the customer finishes his upload, then a message is written to the queue. Then you can either have an Azure function retrieve the message from the queue and create the thumbnails. Each of these parts of processing can be scaled separately, giving you more control when tuning it for your usage. Finally, tables. Azure Tables is now part of Cosmos DB. So in addition to the existing Azure Table Storage Service, there is a new Azure service offering called Azure Cosmos DB that provides throughput optimized tables, global distribution, and automatic secondary indexes. Keep in mind that table storage is a NoSQL database, just like Cosmos DB. But Cosmos DB is much more powerful because it is also called as a planet scale database that is also NoSQL. So you will get throughput and input output at a millisecond level. Your latencies are far reduced when using NoSQL in the form of Cosmos DB. In the next video, let's learn about standard and premium storage accounts in Azure. One size fits all would be incorrect statement when it comes to Azure storage. Every customer has different requirements. Some customer would need a lot of space, whereas others would need a lot of performance. Azure Storage Account is hence divided into two tiers, a standard and premium. Let's talk about them one by one. Standard storage accounts are backed by magnetic drives and provide the lowest cost per GB. They are best for applications that require bulk storage or where data is accessed infrequently. Premium storage accounts are backed by solid state drives and offer consistent low latency performance. They can only be used for Azure Virtual Machine disks and are best with I/O intensive applications like databases. When you are creating a storage account, you will have the options to choose between standard and premium. It is not possible to convert a standard storage account to premium storage account or vice versa. You must create a new storage account with the desired type and copy data. When you create a storage account, you can choose from general purpose V1, and then you also have general purpose V2, then the blob storage. Azure Storage offers three types of storage account, and each type supports different features. And also, it has its own pricing model. Consider these differences before you create a storage account to determine the type of account that is best for your applications. The three storage accounts needs to be discussed one by one. Let's talk about general purpose V2 accounts. The general purpose V2 storage accounts is the latest Azure storage feature, and this incorporates all the functionalities of general purpose V1 and the blob storage account. So the general purpose V2 accounts deliver the lowest per gigabyte capacity prices for Azure storage, as well as provides the industry competitive transaction prices. General purpose V2 storage account supports many services like blobs, files, disk, queues, and tables. Microsoft recommends using general purpose V2 storage accounts for most scenarios. You can easily upgrade a general purpose V1 or a blob storage account to general purpose V2 account with no downtime and without the need to copy any data. So what is general purpose V1 accounts all about? General purpose V1 accounts provides access to all the Azure services but may not have the latest features or the lowest per GB pricing. Legacy account types for blobs, files, queues, and tables is all general purpose V1 accounts is about. So you use general purpose V2 accounts instead when possible. So general purpose V1 was the older method of provisioning a storage account. Finally, the blob storage account. A blob storage account is specialized storage account for storing unstructured object data as block blobs. Block blob accounts provides the same durability, availability, scalability, and performance features that are available with general purpose V2 storage accounts. So blob storage accounts will support block blobs and append blobs, but not page blobs. Just remember this for this time, but moving forward in the subsequent videos, we will talk about what block blobs are, what append and page blob is. But blob storage account offers multiple access tiers for storing data on your usage patterns. So that's about general purpose V2, V1, and blob storage accounts. General purpose V2 is the newest way of provisioning a storage account. V1 is an older legacy type, whereas blob storage account provides just blobs and does not provide tables, queues, and files. Let's learn to create an Azure storage account. I am currently logged into the Azure portal. On the left hand side, you will see all the services associated with Microsoft Azure. Of course, there are a lot more services than these, which can be found in the All Services section. To create an Azure storage account, click on the storage account on the left hand side. It will then take you to another blade or a screen that will let you create more storage accounts here. I already have a storage account. Now this storage account was created when I used Azure Shell to create and provision virtual machines in the previous section. To create a new storage account, I just have to click on add, and this will pop up another section or a blade where I can type in the name, resource group, location, performance attributes, etc. that are required for a storage account to be created. I'll choose a subscription as pay as you go. I will create a new resource group, call it as data store. Say OK. Storage account name. Make sure that this is in lowercase and has no special characters. So if I mouse over this I icon, it will tell you what the requirements of the storage account name are. I'll just give it a name like information hosting. And if somebody else has taken this name, will not get it. That means that this name must be unique and nobody else in the world of Azure must have used it. I'll choose the location as East US, but you can leave it to default. Performance, you can choose between standard and premium, which we discussed earlier. Account kind is general purpose V2, V1, or blob storage. V2 will give me all the features that Azure storage account has as on today. The replication options are not discussed so far, but will be discussed moving forward in the subsequent videos. I'll leave it to LRS, which is local redundant storage at this time. Access tier, we can choose between cool or hot. Again, this hasn't been discussed, but we'll talk about this later. Then we have the networking section. Do you want this storage account to be available on the internet? And if it should be available only in the intranet, then we select the particular networks which are available in our subscription. But if you want your information in the storage account, in your blobs and files to be available all over the internet, then you select public endpoint all networks. If it is private data, confidential, sensitive, patents, intellectual properties, in that case you select selected networks. I'll click on next to move to the advanced section. Now here we have three options: security, data protection, and data lake storage generation 2. Do you want your data to be securely transferred when transmitting data between the storage account to other networks? By default, it is enabled. Data protection, do you want soft delete? So when you enable this, it will let you retain the deleted data for a certain number of days. So any file that has been accidentally deleted can be recovered after the set number of days specified here. So you can scroll all the way to the right to move it to maximum 365 days. So the data that can be retained in this soft deleted section is for 365 days, after which it will be cleaned up. So this is the retention period of your data. I will move it back to the default setting, which is disabled. If your data sitting in your Azure storage account is for analytical purposes, is something that needs to be calculated and is massive in size, then you can connect it to Azure Data Storage Lake Generation 2. This will help you analyze and give information back to you at millisecond latency. So the data lake storage will help developers, data scientists, and analysts to store data of any size, shape, and speed, and do all types of processing and analytics across multiple platforms and languages. I will change it back to default, set it to disabled, and click on next. Tags, as we discussed earlier in the previous sections, tags are used to mark and tag your objects. So I can say that the name is storage and then owner of the storage account is Rob. You can put their email address and say rob at company.com as their email address. So similarly, you can add multiple tags here to the object that we are creating. So this will create a CMDB for me. Finally, you click on review and create, and after the validation, you'll click on create to create the storage account. Looks like the storage account is created. I'll click on go to resource to go to my storage account called information hosting. Now as you scroll down, you will be able to see blobs, files, tables, and queues. So that means that general purpose version 2 will let me create all the full services inside the storage account. So in this video, we'll first create a resource group with PowerShell. So create a resource group with PowerShell, and then we'll also create a storage account with PowerShell. In the previous video, we're doing everything with graphical user interface, and now we're learning to do with PowerShell. Now, if you notice this hash or a pound sign means it's a comment. So when you execute the script, this line number 1 and number 2 will not be executed. This is just for your references. So you can put your reference like that. Say author is Anand. Creation date is whatever. So today is 15, whatever, 2019. Yeah. So you can put your own comments like that. Now, first step that we to create a resource group is to use PowerShell command called new-az resource group. Just say new-az resource group. Right? I'm using tab completion so that there are no errors or any typographical errors in the script. Right? So it's new-az resource group. Then I will say -name. What is the name of my resource group? The name of my resource group is, let's say, payroll. Let's call it as payroll. And the location in which I want to create it is West US. I'm just saying West US here. Now, I could have put these objects inside a variable, right? So I could have just said $location equals West US and put that in double quotes. Yeah. And then I can also say $region resource group name equals payroll. When I do that, I really do not have to use these names like that. I can say dollar resource group name and then dollar location name, right? So the values of the resource group name and the location will be picked up from line number 7 and line number 8 respectively. So when the script executes, line number 9 will look at line number 7 and 8 to put those values here because they have already been declared in line number 7 and 8. Let's execute this and see what happens. I will run this. Line number 1 all the way through line number 9 have been executed. Now it looks like the resource group is created. Now if I do get -az resource group. Let's say tab completion and see what happens. Resource group. And then this time I do not want to hit this button, this play button. Instead, I will use F8 or run current selection. So when I click on this one or hit F8 on the keyboard, it will just execute line number 12 and not line number 1 through 12. If I hit this, which is F5 on the keyboard, it will execute all the lines from 1 through 12. Now I'll just hit this to see the resource groups I have. The one of them that's created is resource group called as payroll. Just looking for that. Yeah, right here. The resource group called payroll is here. So it got created successfully. Next step, what we gotta do is to create a storage account with the same theory. I'll use dollar storage account name. So I'm declaring that first. And the storage account name is called as new storage account. Good. What is the command to create a new storage account? The command to create a new storage account is new hyphen AZ storage account. Look at the IntelliSense. It automatically pops up the possibilities of or the permutations and combinations of this string being inside the commandlet. Okay, so it's new storage account, new hyphen AZ storage account, and this time I want to name the storage account as it's already declared in line 14, which is the storage account name. So I'll say storage account name. I want to put that in a location called, well, I have the location in line number 7, so I will use dollar location here, right? There were other parameters that we looked at when we were creating the storage account using GUI. Some of them were performance tier options. Kind of storage is it? Is it storage account V2, V1, or a blob storage? Do you want Premier? Or what kind of replication do you want? LRS or GRS? Well, those are all the syntaxes that you must punch in before we complete this command. So, starting with SKU. SKU is the kind of replication you want. Well, I will select premium underscore LRS. Then I can also say, well, the resource group name. I can put the resource group name as, well, it's already there. Is it somewhere on the top? Well, the resource group name is right here, $RG name. So, okay, I'll use the same variable. Storage account V2, right? Now let's execute line 16 and see what happens. I'll hit F8 on the keyboard. Well, I got an error message. Let's see what the error message is. Cannot validate parameter name. Argument is null or empty. Well, I think we already have name here. Like that name is new storage account. Well, this is, let's put 123 next to it and see what happens. Okay. Okay, so a few things have been cleared up. I did not execute line number 14 earlier, and there was no value inside this particular attribute. So if you look at this, when I'm executing just this part, there is no value inside it. So after executing line number 14, now I could see the value in it. Let's run line number 16 again and see what happens. There you go. Got an error one more time. The storage account name is already taken. So I will change it to something else. It just says that storage account name 123 is already taken by some other subscription, so I will change it to 3108 or whatever. Yeah, and then execute line 14 first and then line 16. Let's see. Looks like this is creating, so if there was an error it would have populated by now. Okay, looks like my storage account is created. So let's try to do some get operations. So it's a get hyphen AZ storage account, and then we see that the storage account called new storage account 3108 is created under payroll. Let's go to the GUI and see if the storage account is there. There you go. So go back to storage accounts here. There you go. Information hosting was something that we created earlier when creating storage account using GUI, and now we have another storage account called 3108 as well. So everything that can be done with graphical user interface can be done with PowerShell. But today in PowerShell we learned number one, how to comment in your script, second, how to declare variables, and also how to troubleshoot few minor errors that we got when executing new-az storage account. In the next video, let's try to create a storage account with Azure CLI. So far we know how to create a storage account with the graphical user interface. We also know how to do it with the PowerShell. Let's also learn with the CLI. I have the command prompt open and also have the Azure CLI tools installed. So the first command that I will run will create a resource group for me. The command will then be az group create hyphen name, the name of the resource group. You can replace with this part with anything you want, and then the location in which the resource group will be created will be West US. Remember that in PowerShell you will have single hyphens in front of the syntax, but in CMD or CLI you will have double hyphens. Let's hit enter and wait for the resource group to be created. Once the resource group is created, we will create a storage account in the same resource group. All right. Now the command to create a storage account is az storage account create. Right. This part will create the storage account for me. And the name of this storage account is text storage important data. I have chosen this as the name, but you can choose whatever you like. But make sure that you're following the naming standards. Everything is lowercase. There are no special characters, right? There can be numbers inside it, but there cannot be any upper cases. This is created in a resource group called tech underscore itdept. Then the location is in West US. I'm choosing the replication type to be local redundant storage, and the kind of storage is storage v2. So these are various syntaxes that we are passing to create the storage account. These are minimal and required syntaxes that must be there during the storage account provisioning process. I will hit enter now to initiate the storage account provisioning. Looks like the storage account is created. Let's go ahead and go to the GUI to see if it is actually there. I'll go to the graphical user interface, refresh the screen, and there you see tech underscore IT department is there as a resource group. Now inside this resource group, I must have the storage account. So in the last 3 videos, we learned how to create a storage account with the graphical user interface, PowerShell, and CLI. Microsoft has developed an application to connect to its storage account. Microsoft Azure Storage Explorer is a standalone app from Microsoft that allows you to easily work with Azure storage data. There are lots of benefits Azure Storage Explorer has, and it's important to note them. Azure Storage Explorer will let you connect with multiple subscriptions. So if your organization has multiple subscriptions, you will be able to connect to them using one single application. You can view the blob storage, delete, copy blobs, upload and download blobs while maintaining data integrity. Not just blobs, but you can also maintain tables, query the information inside the tables, add, edit, and delete the entities in table, manage the information inside Cosmos DB, create, manage, delete databases and collections. You can manage stored procedures, triggers, and user functions. Not just that, but you can look at the queue storage. You can look up to 32 messages, view, add, and dequeue messages as well. You can connect to the file storage, navigate through the files and directories, upload, download, delete, and copy files, and also edit file properties. With Azure Storage Explorer, you can also navigate through Azure Data Lake Storage, upload and download files into Data Lake, and copy and delete files and folders. I'm now connected to azure.microsoft.com looking at the Storage Explorer options. You can download the Azure Storage Explorer for Windows as well as for Linux and Mac operating systems. This is a downloadable file, and once you have downloaded, you can put your credentials or the SaaS signature to connect to blobs, files, tables, or queues. In the subsequent videos, we'll take a look at each one of these individual sections, see how you can connect using Azure Root subscription and also with SaaS keys. In one of the previous sessions, we spoke about the use cases of blob storage. To create a blob storage, we first need to have a storage account. We have also seen how a storage account can be created in one of the previous demonstrations. To create a blob, what you need is a container. The container resides inside the storage account. The picture here demonstrates the relationship between the resources. Within the storage account, you can group as many blobs as needed in a container. A container provides a grouping of the set of blobs. All blobs must be in a container. A storage account can contain unlimited number of containers. There is no limit to that. Also, a container can store unlimited number of blobs. Everything that you create must be created in lowercase, numbers, and hyphens and must begin with a letter or a number. The name must also be between 3 and 63 characters long. So remember that blobs are sitting inside a container. Container is sitting inside a storage account. You can have unlimited blobs inside a container and unlimited containers inside a storage account.
Enterprises manage different kinds of data. There's some kind of data which is accessed very frequently and needs high IOPS. There's other kind of data that is not accessed frequently and that will need a lot of storage. Sometimes you need to keep backup data or disaster recovery data for a longer period of time. Microsoft has solutions for all kinds of data tiers. So depending on the performance you want out of your data, you might want to keep them in hot tier, cool tier, or archive tier. Let's talk about them one by one. The hot tier. Hot tier is optimized for frequent access of objects in storage account. Accessing data in hot tier is most cost effective, while storage costs are somewhat higher. New storage accounts are created in hot tier by default. So if you're looking for any objects that need very high performance, for example, web applications, picking up pictures and streaming videos from your storage will need high IOPS. They will then go into hot performance tier. Cool tier. Cool tier is optimized for storing large amounts of data. Now these kinds of data are infrequently accessed. They are stored for at least 30 days. Storing data in the cool tier is more cost effective, but accessing that data may be somewhat more expensive than accessing data in the hot tier. Archival data. Now, archive tier is optimized for data that can tolerate several hours of retrieval latency. So your business must be okay with not having that data for a certain duration of time. This archive data will remain in archive tier for at least 180 days. The archive tier is the most cost-effective option for storing data, but accessing the data is more expensive than accessing data in hot or cool tier. So when you put data in archive tier, do not access that very frequently. The whole purpose of putting data in archive tier must be to store it for a long period of time, which is at least 180 days. Azure Storage provides different options for accessing block data based on the usage patterns. Now, each access tier that we just discussed is optimized for particular pattern of data usage. By selecting the right access tier for your needs, you can store your blob data in the most cost-effective manner. We know that one component of a storage account is Azure Blobs. There are others as well. You got files, queues, and tables. But blobs are again of different types. A blob can be any type and a file size. Azure Storage offers three types of blobs. There's a block blob, page blob, and append blob. You specify the blob type when you create the blob. The default is a block blob, but we need to understand each type individually. Let's talk about block blob. A block blob consists of blocks of data assembled to make a blob. Most scenarios using blob storage employ block blobs. So this is more of a block storage.
A block blobs are ideal for storing text and binary data like files, images, and videos. What is an append blob? Append blobs are also like block blobs, but they are made up of blocks, but they are optimized for append operations. When does an append operations happen? It happens when you're logging, when you're writing events one after another. So append blobs are optimized for logging scenarios. Page blobs. Page blobs can be up to 8 terabytes in size. They are very efficient for frequent read-write operations. And when does read-write operations happen very frequently? On a virtual machine. So Azure virtual machines will use page blobs as operating system disks and data disks. Remember that once the blob has been created, its type cannot be changed. So you can also upload a local file to a blob storage using PowerShell commands. There are lots of blob upload tools that we use as on today. Administrators love to use AZ-copy. Now, AZ-copy is a very easy to use command line tool for Windows and Linux that will copy data to and from blob storage across containers and also across storage accounts. There is another library which is called as Azure Storage Data Movement Library. It is a .NET library for moving data between Azure storage services. So the AZ copy utility is built with the data movement library. Now, if you got lots and lots of data, you will use Azure Data Factory. Azure Data Factory supports copying data to and from blob storage by using the account key, shared access signature, service principal, or even managed identities for Azure Resource Authentication. There's another service called as Blob Fuse. Blob Fuse is a virtual file system driver for blob storage. So you can use Blob Fuse to access your existing blob data in your storage account. This is specifically for Linux file systems. Azure Data Box Disk is a service for transferring on-premise data to blob storage when you got large data sets or when you have network constraints to upload data over the wire unrealistically. You can use Azure Data Box Disk to request for SSDs, which are solid state disks from Microsoft. So you can then copy your data to those disks and then ship them back to Microsoft. Microsoft will then upload it to your blob storage. This is called as Azure Data Box Disk. There's another service from Azure which is called as Azure Import and Export. This import export service provides a way to export large amounts of data from your storage to hard drives that you provide and that Microsoft then ships back to you with your data. Of course, we discussed about Azure Storage Explorer. You can always install the Azure Storage Explorer utility to transfer data back and forth from your Azure Storage account to your on-premise infrastructure.
It's always important to have additional layer of security. Access policies provides additional layer of security and control over shared access signatures. It provides you the privilege to grant access and tells you how much of permissions do you want to grant to a shared access signature. Not just that, you can specify the start time, end time, which is also called as expiry time. And not just that, you can have the time zone level access as well. So people should be able to access it only from a particular time zone. A stored access policy provides an additional level of control over shared access signatures. Establishing a stored access policy serves to group shared access signatures and to provide additional restrictions for signatures that are bound by the policy. You can use a stored access policy to change the start time, expiry time, or permissions for a signature, or to revoke it after it has been issued. A stored access policy on a container can be associated with a shared access signature, granting permissions to a container itself or to the blobs it contains. Similarly, a stored access policy on a file share can be associated with a shared access signature, granting permissions to the share itself or to the file it contains.
A shared access signature SAS will be covered in more detail in the last lesson, which is storage security. By this time, we understand the importance of storage accounts. Storage accounts also use a pricing model. That means everything that you use in cloud, in Azure specifically, is chargeable. So when you're designing storage solutions in the cloud, always think about pricing model. How much are we going to pay? What do we pay for? Are we going to pay for data storage or transaction costs? In this video, we'll understand how the storage will impact the pricing. Let's talk about the performance. For mission critical applications, you are expecting least latency and good throughput. So, in addition to the amount of data stored, the cost of storing data depends on the storage tier. The per gigabyte cost decreases as the tier gets cooler, and as the storage gets hot, the per gigabyte cost will increase. Data access charges increases as the tier gets cooler. For data in the cool and archive storage tier, you are charged a per gigabyte data access charge for reads. Transaction costs. There is a per transaction charge for all tiers, and this will increase as the tier gets cooler. Geo-replication data transfer costs. This charge only applies to accounts with geo-replication configured, including GRS and RAGRS, which is read access only geo-replication costs. Geo-replication data transfer includes a per gigabit charge. When you choose geo-replication, you are replicating your data between two geographies, and that also includes the network transfer costs. How about outbound data transfer costs? Now, outbound data transfer is the data that is transferred out of an Azure region. So outbound data transfers incur billing for bandwidth usage on a per gigabyte basis. Changing the account storage tier from cool to hot incurs a change equal to reading all the data existing in the storage account. However, changing the account storage tier from hot to cool incurs a charge equal to writing all the data into the cool tier. These storage accounts that you see are as a result of our previous lab activities. Let's go ahead and create a container in this lab and then look at the options we discussed in the previous videos. Now, to demonstrate this, I'll click on Information Hosting and then create a container in the blob. Now I can either click on the blobs option right on the dashboard or scroll down to the point where we see blob service. Under blob service, if I click on blobs, you will then see an option click and create a new container. So once I click on this, you will then see these options: private, blob, and container. We learned about these options in the blob containers video. Now if I click on private, it means I do not want to give access to anybody on my blob. I will give it a name and call it payroll data and say OK. That means nobody will have permissions on it. It's a privately accessible container. Inside this container, you're now ready to upload the blobs kind of data you want. You can upload pictures, JPG content, MP4, documents, DOCX or PDF files inside it by just clicking on the upload button, right? You can always change the access level by clicking on the change access level button and then granting access to people whom you want by saying blob or container. If I click on upload button, it will then open a blade on the right hand side. And then you can browse and start uploading the data. When you're uploading, you can always choose whether it's a block blob, page blob, or append blob, depending on what kind of data you're uploading. Now we spoke about these options when we were talking about blob performance tiers. I will upload a file here just for demonstration purposes. We created this script earlier, install webservice.ps1. I'll just upload that and leave it as block blob. And then finally click on upload. You will say that it uploads pretty quickly and then it's available right here. So anybody who has access to the payroll data container will then be able to access my file in the payroll data container. By default, every file is categorized as hot tier.
If you would ever like to change the tier of this access tier from hot to cold or archive, all you have to do is click and select the file, then click on change tier on the top right hand side. This will then give you the options to change the tier of your blob file. It could be hot, cold, or archive. We spoke about these options in detail when we were talking about uploading blob video section. I'll change it to cool and then click on save. It takes less than a millisecond to do that. Now go back to payroll data. Now you will see that the access tier is set to cool. You can upload multiple files, so a bulk upload is also acceptable in the container. You can also do similar activities using Azure Storage Explorer. We did the demonstration earlier, but you will be able to create containers, upload blobs, files inside the container using Azure Storage Explorer. File storage. File storage can offer shared storage for applications using industry standard SMB protocol. Microsoft Azure virtual machines and cloud services can share file data across application components via mounted shares, and also on-premise applications can share files through this share. Applications running in Azure virtual machines or cloud services can mount a file storage share to access file data. And this would be just like a desktop application that will be mounted as a typical SMB share. Any number of Azure virtual machines or roles can mount and access file storage share simultaneously. And that brings Azure Files to several use cases. Azure Files can be used to completely replace or supplement traditional on-premise file servers or NAS devices. You can access these file shares from anywhere. And that means that popular operating systems such as Windows, Mac operating systems, and Linux can directly mount Azure file shares wherever they are in the world. Lift and shift. Azure Files makes it easy to lift and shift applications to the cloud that expect a file share to store file applications or user data. Azure file shares can also be replicated with Azure File Sync to Windows servers. They can be either on-premise or in the cloud. This is good for achieving high performance and also distributed caching of data wherever it's being used. Shared applications. Storing shared application settings. For example, in configuration files, you can use Azure File Shares. You can also use Azure File Shares for storing diagnostic data such as logs, metrics, crash dumps in a shared location. File shares are also used for storing tools and utilities needed for developing or administering Azure virtual machines or cloud services. Which of these use cases for files will you be most interested in? Let's understand when to use files versus blobs. Azure Files offers fully managed file shares in the cloud. These are accessible through industry standard SMB protocol. Azure File Shares can be mounted concurrently by cloud or even through on-premise deployments on Windows, Linux, or macOS. Additionally, Windows file shares can be cached on Windows servers with a feature called as Azure File Sync. This is done for fast access near where the data is being used. Sometimes it is difficult to decide when to use file shares instead of blobs or disk shares. Please take a minute to review the table that is attached as a resource section in this video. Azure files are accessed through file shares, but Azure blobs are accessed through containers. Azure files provide shared access across multiple virtual machines, but Azure disks are exclusive to a single virtual machine. When selecting which storage feature to use, you should also consider pricing. Let's go talk about creating file shares in the storage account. In the previous sections, we looked at how you can create blobs and then create containers. We do the same thing with files, but in files, you create file shares. You can either create files by clicking on this little button here under the overview section, or scroll down till the point you see file services. Both of them will bring you to the same interface. Now click on one of these and then you will have the options to create a file share. You can define, of course, the name and also the amount of data maximum amount of data that can fit inside this file share. You can define in gigabytes. So this time I'll specify 1024 GB and also give it some name, marketing, and then go ahead and create it. Now that it is ready, you can click on this marketing and start uploading content inside it. Uploading data is really not a big deal like you saw in the previous blob section where we were uploading data into the containers. So you can just click on this browse button and then upload files just like that. It's pretty simple. But what's important here is to connect it and mount it as a drive on your Windows and Linux based machines. And to connect it to your Linux or Windows based machines, you can click on this connect button and then you will see several commands for both Windows and Linux. For Windows you will see test-connection for PowerShell based command, and this is a command line based command. If you have a Linux machine, you can use mount, which is sudo mkdir mounting on a particular drive. You also have similar set of commands for Mac. I have a Windows based machine ready and we can test one of these commandlets right now. I'll go to virtual machine section and open a new tab so that I can see my virtual machine, RDP to it, and use either the PowerShell based command or the CLI based command on my Windows machine. Let's get started with it. So here's my virtual machine which is running and its public IP address is follows, and I'll copy this and RDP to the Windows based machine. Alright, I'll quickly type the user ID and password. Okay, now that our Windows machine is up and ready, I will launch PowerShell on this machine to execute the command shown in Azure. To launch PowerShell, I'll click on Start and then just type PowerShell there. Okay, usually have the habit of opening the PowerShell ISC. While it is loading, I can just minimize this and go back to Azure file share and copy the command here. Now before copying this command, I'll show you something else. It's a drive letter that you can choose. You can choose between all the alphabets all the way from A to Z. So if you say, let's say you select T, then your drive will be T drive. Yeah. Now if you scroll down here in the command, you will see somewhere that it is mounting it to the T drive. I'll show it to you once we go into the virtual machine right here. Then we can look at the command here in the PowerShell ISC. Okay, so looks like this is testing the network connection to the endpoint called information hosting.file.core, and this is the SMB protocol 445. It is invoking an expression, and here is the drive name, new-ps drive-name T. So your drive name will be T. And if I scroll to the right, you will also see the username that it's using and the password, which is nothing but the key that it is using to connect to the drive. This random gibberish alphanumeric string that you see is nothing but a key that will be used to connect to this file share. Let's execute this. Let's run it, give it a few minutes. It was able to establish a first TCP handshake and successfully mounted my T drive, right? So let's try to navigate to the T drive right from here. Okay, and now if I do dir, what should I have in my drive? Remember, there was a PowerShell file that I uploaded. It must be visible in the directory. There you go. Install web service.ps1 is right there. So anything that you upload through the Azure portal will be visible here. In the next video, we'll see how you can create a file share using PowerShell. In this video, I want to show you another method of creating a file share. Now, this will be using PowerShell. Once the file share is created, we'll mount it on, let's say, a Linux machine this time. Last time we learned how do you mount it on a Windows-based machine,
And this time we'll learn how do you mount it on a Linux-based machine. The only difference is that now we are creating a file share using PowerShell instead of the graphical user interface. Now I'll go to this storage account, and this is where we have to create the file share. So once the file share is created, it should be visible under this section, right under marketing. And like I said, we have to do it using PowerShell and not with graphical user interface by clicking on this button. That's not what we want to do. So I'll go back to the PowerShell here. And well, these are the two things that I want to achieve here. Number one is to retrieve my storage account information and then get the permissions using storage account key. Now this is something new here. And once both of these steps are done, we'll go to step 2, which is creating the file share. This is pretty easy, but retrieving storage account and storage account key is an important section. Let's see how we do that. The command to retrieve the storage account is new-az storage context. So I'll just type that, new-az storage context. I'll just do a tab completion, and then I will type my storage account name, which is, just copy from here, which is information hosting, and yeah, like that. And then what I will also need is a storage account key. Okay, now where do we get the storage account key from? You get it from the settings. So I'll scroll up to the top here. Under settings, you will see something called access keys. On the right hand side, you will see two keys, key 1 and key 2. You can either copy key 1 or key 2, doesn't matter. So I'll copy this key and just paste it in PowerShell. Now, if I execute this, you will see that it has retrieved all the information about that storage account. You can actually flip it like that, side by side screen. It has got information about the blobs, tables, queues, and files of that storage account. What I would like to do is store this information inside a variable, and I'll call it as, let's say, storage context. Okay, and I will execute this one more time. Now what I have inside this variable, I'll just execute that. See, you got all that information about the storage account inside the $storage context variable. Now it's time to create a new file share. The commandlet to create a new file share is new-az storage share. You have to provide a file share name as well, and I'll call it as important data. Important data, IMP data, will be the file share name. Then I have to provide the storage context as well. So I'll use the syntax -context is $storage context. So now it knows where to go and create that file share. I will also put that inside a variable called $share equals that. So just in case I may need it after executing it. Now let's play the whole thing. Great. So I have an error that the given share name important data is not a valid name for a file share of Microsoft Azure file service. So there is something that I need to do. And that something is that changing the name here. Uppercases, special characters, they're not allowed in a file share. I'll just change this to lowercase and execute this one more time. Let's give it a shot. Alright, looks like it is successful. Now let's go back to the graphical user interface, or let's pull it up from right here. What is the share name? Yeah, it is important data. It's created. So I'll go back to the graphical user interface, go to the files section, and then I must have two file shares. One is marketing, which was created in the previous video using the graphical user interface, and IMP data is something that is created using PowerShell. Let's click on connect, and then in the previous video we used PowerShell to connect to the Windows-based machine. Now we can use Linux as well. I have a Linux machine ready, so I can SSH to it and then run the mount command to mount it as a drive. I'll copy this, the whole thing, and SSH to this. So I'll putty. Just have to launch putty here. Yeah, paste it. Oops. Okay, I've got something else in my clipboard. We got 40.121.69.63. Okay, there you go. Connection established. Type the user ID and the password. Okay, a few seconds and it should give me the prompt. There you go. I've got the CLI ready for this. I'll copy this one more time and go back and execute that. Now before I do it, I'll just run df command here to see how many drives I have, and then I can run this df command one more time to see if my drive is actually mounted. So yeah, so something happened in the backend. I'll do df one more time, and now I see that a file share based on Windows is mounted and the file share name is important data. So we can navigate to this and start pumping in information inside that drive. In this video, we learned how you can create a file share using PowerShell. Then we'll connect it to a Linux-based machine, executed these commands, and mounted the drive as a volume on a Linux machine.
Securely transferring your critical data, intellectual property, patent, and all such confidential information is really important for an organization. Azure Storage Account provides an option for you to securely transfer the data. The secure transfer option enhances the security of your storage account by only allowing requests to the storage account by a secure connection. For example, when calling REST APIs to access your storage account, you must use HTTPS. Any request using HTTP will be rejected when secure transfer required is enabled. As you see in the screenshot, secure transfer required is an option under configuration in settings. When you are using the Azure file services, connection without encryption will fail. And that includes the scenarios using SMB 2.1. SMB 3.0 without encryption will also fail. And certain versions of Linux SMB client will also fail if the secure transfer required is enabled. You can toggle between disable and enable with PowerShell also. And here's the command to use PowerShell. Set-AZ storage account, and you can use the syntax called -enable HTTPS traffic only and set it to Boolean value true to enable the storage account. You also have to specify the storage account name and the resource group, of course. Because Azure Storage Account does not support HTTPS for custom domain names, this option is not applied when you're using a custom domain name. If you are from the virtualization world or from the infrastructure side of IT, you know what I'm talking about. Snapshots. Snapshots are nothing but point in time, read only copy of your data. Let me explain that with an example. Let's say you're working on your file share and all of a sudden you accidentally delete some data. Or maybe you ran a script that accidentally deleted a bulk of data. How will you get back your data? If you had taken backups or if there was a snapshot that can restore it back in time. Azure File Share Snapshots is just that. Azure Files provides the capability to take snapshots of your file shares. Share snapshots capture the share state at that point in time. It is just like a photograph. It's like capturing your smile for that point in time so that you can go back and look at your photograph and see how you look like. Similarly, if you want the data at that point in time, let's say how your data looked 3 weeks ago or 4 weeks ago, you can restore from that snapshot. Share snapshot capability is provided at a file share level. Retrieval is provided at an individual file level so that you are allowed for restoring individual files. You cannot delete a share that has share snapshots unless you delete all the share snapshots first. It's like a dependency. Also remember that share snapshots are incremental in nature. Only the data that has changed after your most recent share snapshot is saved. And this minimizes the time required to create a share snapshot, saves on storage costs as well. Even though share snapshots are saved incrementally, you need to retain only the most recent share snapshot in order to restore the share.
So when do you use these share snapshots? What is the use case? As we just said, you will be protecting against data corruption. Applications that use file shares perform operations such as writing, reading, storage, transmission, and processing. And if an application is misconfigured or has unintentional bug that is introduced, probably there's an accidental overwrite or damage can happen to a few blocks. To help you protect against those scenarios, you can take a share snapshot before you deploy new application code. If a bug or application error is introduced with a new deployment, you can go back to the previous version of your data on that file share. How about protecting from accidental deletions or unintended changes? Needless to explain this, imagine that you're working on a text file in a file share. After the text file is closed, you lose the ability to undo any of your changes. In these cases, you will need an option to recover a previous version of the file. You can use share snapshots to recover previous versions of the file if it's accidentally renamed or deleted. You can also use these share snapshots for general backup purposes. So after you create a file share, you can periodically create a share snapshot of the file share to use it for data backup. A share snapshot, when you take it periodically, it will help you maintain previous versions of the data that can be used for future audit requirements or disaster recovery. In the next video, let's go ahead and take a look at the demonstrations as to how you can take snapshots and restore them.
As we know that file share snapshots are very important for restoring information from a previously snapshotted version. So in this video, let's go ahead and see where you can take the snapshot of the file share and also ways to restore it. Now I'll click on the information hosting file share, then scroll down to the point where I see file service and click on it. Now as you see, there are two file shares that we have created in our previous lab activities. I'll click on one of these, and then you will notice on the top right hand side there's a create snapshot button. I'll click on it, and because there's very less information inside it, the size of the snapshot will also be small. Amount of time it takes to create